All right, let's dive right in. Today, we're going to talk about a fascinating and very physical problem right at the heart of artificial intelligence. We're going to pull back the curtain on this unseen barrier that exists between a powerful AI and the computer it runs on. And it's a barrier that explains a lot, like why the most advanced AI can't just live on your phone.
So you've probably wondered this, right? The most powerful, absolutely mind-blowing AI models seem to live way up in the cloud somewhere, running on these massive servers. So why can't we just download one to our phone? Well, it turns out it's not a software issue. It's a very real physical barrier that we're about to break down together. So first up, AI's big memory problem. This is where we're going to unpack the physical limits that really control where and how powerful AI can even operate. Okay, to really get a grip on this, we need a simple analogy. Let's call it the workbench and the blueprint. This simple idea is going to be our guide for understanding this whole kind of complex relationship. Here they are, our two main players. On the left, we've got the workbench. That's your computer's RAM. It's active memory. It's where all the work actually happens. And on the right, we have the blueprint. That's the AI model itself, the super detailed plan with all the instructions. And obviously, to build anything, you need both. Let's get a little more specific. What is RAM? Well, it stands for Random Access Memory, and you can just think of it as the computer's high-speed temporary workspace. But here's the absolute crucial part. For any job to get done, the instructions, the blueprint, and all the tools you need have to be laid out on this workbench. If it doesn't fit, you just can't work. Simple as that. So what about that blueprint? Well, that's the neural network. It's this massive, incredibly complex AI model, and it's built from millions, or these days, literally billions of things called parameters. Each one of those parameters is like a single tiny instruction on that gigantic architectural blueprint. So the more parameters you have, the more complex and detailed your blueprint is. Okay, so we've got the blueprint and we've got the workbench. How do they actually come together? In this next part, we'll see exactly how the AI model gets put to work. The workflow seems pretty simple, right? But it has one critical, absolutely non-negotiable rule. The entire blueprint, the whole neural network, every last page has to be loaded onto the workbench all at once. Only after it's totally unrolled in RAM can the computer actually process your question and give you an answer. And that right there, that brings us to the core conflict of this whole story, the great memory bottleneck. This is where we have to ask the big question. What on earth happens when your blueprint is just too big for your workbench? Because that's exactly what's happened. You know, in this intense race to create more and more powerful AI, these blueprints, these neural networks, they haven't just gotten a little bit bigger. They have exploded to an absolutely astronomical scale. And this is where it gets really wild. Take a look at this number. A modern, large-scale AI model can have 1.6 trillion parameters. Think about that. That is a blueprint with 1.6 trillion individual instructions on it. The scale is just, it's almost impossible to wrap your head around. So what does that mean in the real world? Well, here's the kicker. Just to load that one single blueprint onto the workbench, you need about 3.2 terabytes of RAM. Yeah, terabytes. Your high-end laptop might have, 16 gigs? Maybe 32 if you're lucky? We're talking about more memory than hundreds of powerful laptops all put together. All of a sudden, it becomes crystal clear why this can't run on your phone. This quote really just hits the nail on the head. The size and therefore the power of an AI model is literally limited by the amount of workbench space you have. This isn't a software problem you can just patch. It's a fundamental hardware bottleneck. And this is why powerful AI lives in these huge data centers with custom, basically room-sized workbenches. But hey, the story doesn't end there. Faced with this massive physical barrier, engineers are now focused on working smarter, not just bigger. They're coming up with some really ingenious ways to rethink both the workbench and the blueprint. People are exploring four main paths right now. First, new hardware, which is pretty straightforward. You're literally just designing bigger, more efficient workbenches. Makes sense. Second is something called model compression. This is like figuring out how to print the blueprint in super high res, but on a much smaller piece of paper. Third, you've got efficient algorithms. This is a clever trick for folding the blueprint in a way that you only need to look at the one section you need for a specific task. And finally,
distributed computing, which is wild. It's like getting thousands of workbenches to all work together, each one handling a tiny piece of a single colossal blueprint.
So, why does all this innovation matter? Well, the ultimate goal here is huge. It's about breaking AI's dependence on these giant, power-hungry supercomputers. It's about making this incredible technology more accessible to more people, more efficient to run, and honestly, a lot more sustainable for the planet.
And that leaves us with one last, pretty important question to think about. As these AI blueprints continue to get even larger and more complex, who will actually have the massive workbenches, the resources to build and shape the future of this technology? It's a question that really gets to the heart of access and innovation in this new age of AI. Thanks for joining me.